I get an insane number of 0.008% probability of Rinku Singh hitting those 5 sixes in the last over. What a guy. Hello everyone, Shrey here. So today we'll talk about the most thrilling match of IPL 2023 yet, that is Gujarat Titans versus Kolkata Knight Riders. Rinku Singh, you beauty. 29 runs needed of the last over and he did it. He did the impossible. But how hard was it? What was the probability that he could do it in that match? Spoiler alert for those who do not want to know the calculations behind this, it was just 0.008%. But how did I calculate this? I used Poisson Distribution. So in this video, I'll first explain what a Poisson Distribution is, then relate it to cricket and how we can use it for our analysis of Rinku Singh's amazing innings. So what is Poisson Distribution? So imagine you're a farmer and you want to know how many eggs your hens are likely to lay in the next week. So the Poisson distribution can help us figure out how many eggs you're likely to get in the next week based on how many you have been getting in the past few weeks. So similarly, when we're talking about a cricket match, we could simply analyze the number of sixes getting hit in an over and calculate the probability of the number of sixes in the next over. So in our case, we would first look at the 39 overs, like the 20 overs of the first innings and the 19 overs of the second innings that were bowled, and then calculate the probability of 5 sixes getting hit in the last over. But first, let's just look at the different functions that we have at our disposal to calculate the Poisson distribution. So coming back to our hen example, let's say we have a hen which on an average is laying about 5 eggs a week. So setting the mean as 5, we can calculate the probability of the hen laying exactly 3 eggs in the next week. So to do that, we use the depoise function. We enter the value 3 and we enter the mean. So if we run this and print the probability, we get a probability of about 14% that the hen would lay 3 eggs in the next week. We can use the ppoise function to calculate the probability of getting up to 3 eggs. That means the hen might lay 0 eggs, 1 eggs, 2 eggs, or 3 eggs. So if we just do ppoise 3 and the mean, we see that there's a 26.5% chance that the hen might lay up to 3 eggs. Ppoise is simply the depoise function, but taking into consideration all the possibilities and the sum of it. So if I do this, it will give me the exact same number. But this is just for convenience. We can use the qpoise function to find the smallest number of eggs you might get with a 25% chance or less. So now we are just reverse engineering this thing. We are giving the probability and just checking what is the amount of eggs. So if we are like writing 0.25 as in 25% chances, then I'm just saying I might get up to 3 eggs. And the rpoise function is to generate 10 random number of eggs, like just like if we don't have a sample with us, we could use rpoise to generate some samples of the number of eggs. So if I'm saying I have a hen which is laying 5 eggs a week, I can generate 10 samples of some similar behavior of the hen. So I have like the hen laying 5 eggs, 6 eggs, 7, then 4, 8, 7, 6, 3, and so on. So this is like generating an artificial hen's numbers. So now let's come to cricket, and before that, let's just do some data wrangling and get our data ready for our analysis. Remember, what we want is we want the number of sixes per over in each innings. So we just start off with loading the library first. We only need one library for now. We have our data ready in a CSV. So I just read the CSV and just have a simple look on what the data looks like. So if I just go over here, I have the match, season, start date, innings, ball, and batting team, bowling team, and so on. I'll add the CSV in the description below. So once I read the CSV, I notice that this ball column over here, like if I if I run this, yeah, the ball column over here contains both the over and the ball. So we need to separate this into over and ball columns separately. So I just use the function separate the ball column into over and ball. So as soon as I run this, I'll have this one column separated into two parts. As soon as I do this, I have over and ball. But now I notice that the over and ball are both in character. I need them to be in numeric form. So simply I do a mutate. This is used for adding or mutating columns. I do over as numeric. Okay, this will convert the over to numeric. I also add over is equal to over plus 1 because this is technically the first over. This is not the 0th over. So I just do over is equal to over plus 1, and then I convert the ball column also into numeric, and I'll have clean data after this. So if I run this, I have clean data for myself for my analysis, which contains innings, over, balls, and the main thing that I'm concerned with is the runs off the bat. I want to calculate the amount of sixes. So going back to our code, I'll just first select the columns that I need. So I have innings, overs, and runs off the bat, and I'll generate an artificial column now, which will tell me whether in that particular over I have a 6 or not. So I'll just mutate 6 in over as a column. So if the runs of bat is 6, then I'll add a 1, otherwise I'll add a 0. So this will help me calculate the number of sixes per over, and you'll see how. So if I just run this, I have a new column. It's 0 for now because there are no sixes over here. But if I just view it like this quickly, and I filter for sixes and over as 1, you see the first 6 was in the over 9 of first innings, and the runs of bat is 6. So I just added a 1 number, and you'll see why. Now if I just want to have the sum of sixes per innings per over, what I'll do is I'll group this entire data by over and innings and summarize the count of sixes as the sum of my new column. So let's say I have 6 on the first ball, so 6 in over will have 1. I'll have 6 on the second ball, the 6 in over will have another row containing 1. So however many sixes I have, I've just added a row saying 1 1 1 to it. So if I have 3 sixes in an over, when I do a sum of the number of sixes grouped by over and innings, I'll have the count of sixes basically. So if I just summarize this for you, you'll have a better idea. Yeah, now I can clearly see over 1, innings 1, the count of sixes is 0, and over 3 in innings 2 has count of sixes as 1. But let's just view it properly by arranging it by the innings first. So if I run this, I have the first 6 of the first innings on over 9th, and I can just view this for a sanity check. I can see that the next 6 was in over number 12 and so on, and the last over of the first innings had 3 sixes. Perfect. And we'll just do our sanity check for the second innings, and this is correct, as in the last over of the second innings has 5 sixes in it. So we have our data ready now. And what we want to do over here is we want to filter out the last over, because our sample for our probability would only contain the first 39 overs. So I'm just slicing off the last over. Just to explain it again, why am I doing this? Because we want to calculate the number of sixes that were probable in the last over. So we cannot include the actual number of sixes hit in the last over. So we just need the first 39 overs of how the game is being played and how many, like what's the trend and all. So we'll just take the first 39 overs and skip the last over, for which we have to calculate the probability. So if I just do this, I have my 6 data ready. Now I just need to calculate the probability of exactly 5 sixes being hit. So for that, I just need the mean and one of the functions from the library that we have. So the mean number of sixes would be the 6 data and the count of sixes. So if I just run this, I have these sixes, and if I just run, I have the mean as 0.436 being hit per over. Now we have the mean. Now we want to calculate, if we have the mean as 0.436 being hit per over, what is the probability of 5 sixes being hit in the next over? To calculate the probability of hitting exactly 5 sixes in the last over, we use the Poisson function. As you remember from the hen example, we get the probability of the exact number of events happening. So 5 is the number of sixes that Rinku Singh hit, and lambda is the mean sixes, that is 0.43. So this will give us the probability. If I run this, I have some number, but I want to just convert it into a percentage because the probability will be from 0 and 1. So if I run this, I get an insane number of 0.008% probability of Rinku Singh hitting those 5 sixes in the last over. What a guy. So now that we're done with the calculations, and you can see that it was such an easy calculation. Note that this calculation assumes that the probability of hitting a 6 in a given ball is constant and independent of other balls, which may not be true in practice. So for example, it's a no ball and the batsman is free to hit without the fear of getting out. So the probability of hitting a 6 is high. And there are a lot of other factors that might affect the scenario in that game. So I agree, a lot more complex analysis can be done by adding a lot more variables to calculate the chance of 5 sixes in that last over. So this video was more on understanding Poisson distribution, and I hope you liked it. See you in the next.